Now, let us look at the example and apply the calculator instructions to tackle the statistics problems in grade 12. Now, let us see what we do here, grade 12. Now, we are told that the table shows the results for 5 grade 12 learners in mathematics and science. Now, in most cases, the examiner will indicate for you which one is X and which one is Y. However, we can also check the X value will be the first there and the Y value will follow in the table unless stated otherwise, or maybe when you are working with variables that you know that time will be on the X-axis in most cases. Now, so in most cases, how the table is given to you, X will be on top, Y will be at the bottom. However, like I said, unless it is stated otherwise, so it's not always the case, right? So what we do, number A, we are asked to draw the scatter plot. So let us now go and find solutions of number A. So number A says draw the scatter plot. Remember, this is my X, this is my Y. So on the X-axis, I will find the science. So that's where science is. On the Y-axis, we have the mathematics marks. So what do? You just plot the points as they are. So 64 is to 54. So that's how you get the point there is 64 there. You find it somewhere there. And the 54 that you just get there. Then that is the point that you plot. And you do the rest for all of those points. Remember, this is a scatter plot. You don't have to you are not restricted which value you can start with. You can start with the 72 over 64. You will yield the same result. So you can plot from wherever, or you can start with any. Second question says determine the equation of the line of best fit of the data. So in this case, what do? We utilize the calculator instructions where we'll find our A in this case will be 1. Our A will be 6,1 and our B, which is Bx there, will be 0,81. So those are the values that we'll get from the calculator. Remember, when you present the calculator instructions, on the y-axis values, you'll put all of these values. You'll just say 64 equal sign, 88 equal sign, 52 equal sign, 46 equal sign, 72 equal sign. You go to the y side, you now say 54 equal sign, 8 equal sign, and you proceed in that manner, right? So this is what you get. You find the value of A, you find the value of B, then what do? You substitute in the equation that said y is equals to bx plus A. So that is to say, in the space of A, you will have the 6,1 in that case as we do, and in the space of B, we'll have the 0,81. So that is how we find the equation of the line of best fit. And also there's the determine the mean point of the data. We'll also use the calculator instructions, and this is our x value of the mean point, and here we have our y value of the mean point, right? So these are the values. After you find the mean point, it is always best to do what? Plot it on your scatter plot. So this is our mean point there. So you can see I plotted there. So x value is 64,4. So 64 is somewhere here. 4 will be somewhere there. And the y value is 58,4. So it's just below 60 there, as you can see in that case. Then we proceed. Now let us look at number D. So the D says draw the line of best fit on the scatter plot. Remember, the equation for the line of best fit, it was A plus Bx. So y with the head there. So A is 6.1 and B is our 0,81. Then x is an x in that case. So remember, this line, it passes through the mean point and the y-intercept. What is the y-intercept? Two ways you can do it. You know, when y-intercept, x is equal to 0. So in this case, in our equation, 6,1 plus 0,81. Then when you put x there as 0, you can see this will give us 0, will remain with y is equal to 6,1. So this y-intercept 0, this y-intercept, our 0 is to 6,1. We're saying it's x, and this is our y value in this case. So this is A. So in most cases, that y-intercept there, it is your A, right? Then what do? You plot the mean point, we did. Then you plot that one, you go to 6,1 is 10 below there. You do that. Then you connect a straight line between the y-intercept, you draw it, you connect it with the mean point. The line will just go there with a ruler in that case, right? So that line will see that most points are gonna be, if this is a strong correlation, most points will be around that line, right? So this line, it represents what? It represents our trend. So you can see it went where the points are, as the most points are populated around this area. If you can see, maybe you can see the points are there, the line is no way that it can be here or it can be somewhere there. It will always go where most points are. If it's a strong relationship, if it's the negative relationship, you will just see how the line will look like. We'll do that later. Right. Now, determine the correlation of coefficient and comment on the strength. So what you see there, our R is equal to 0.97. Remember, we find our R from the calculator instructions. So this gives us a strong positive correlation. So this is our comment. You can see that most points are actually around the line of best fit. That's why we have a strong positive correlation. If most points were far away from this line, we're going to have a we're going to have a weak positive correlation if they were still increasing in that case. Now, in most cases, we'll use this R when you look at the reliability of this equation. So in most cases, what we're saying is when our R is strong, then the estimated values we can get from our equation or the line of best fit there, the equation of the line of best fit, then we'll say those values that we can get or we can estimate, they will have or they will yield a strong, they will be more reliable. So this R, we'll use it when we extrapolate and interpolate, where we're saying when R it is giving us a strong value, whether a strong negative or a strong positive, then the equation it is bound to give us the estimates that are reliable. So that's what we are doing in this case. Now, let us look at number F. Number F says to us, if a learner obtained 38% in mathematics, predict the mark that they will get in science. Now, what do you do when you have such a situation? We are given 38% and the 38% is in mathematics. First thing that you do, you check where is the mathematics plotted. Is it on the X or it's on the Y? So when you go to our scatter plot, we can see that our mathematics, it is plotted on the Y. So that means this 38%, it represents our Y value. So in this case, our Y is equal to 38. How do you know that? Like I said, you go to a scatter plot, you check where is math, where is science. So math is on the Y-axis and we are given the math value. That means that value that we are given for mathematics, it is on the Y-axis. So that is to say, in our equation, where there is Y, we'll put that 38. They say now, predict the mark that they will get for science. So we'll use the equation of line of best fit, which is Y is equal to 6,1 plus 0,81x. Then we substitute Y is equal to 38. Remember, I just mentioned that to say, because mathematics is on the Y-axis and we are given mathematics value, then this 38 will represent our Y and solve for X because we are looking for science. Where is science? Science is on my X-axis. So this is my X and this is my Y. So that is very important for us to know here. So that is to say, we code down the equation Y is equal to 6,1 plus 0,81x. Then in the space of Y, what do we substitute? We now substitute 38 is equal to 6,1 plus 0,81x. Then we solve for X in that case. We find our X as 39,98. So that is to say, a learner who gets 38 in math, who obtained 38 in mathematics, we can predict that the learner would get or might get 89,38 in science. So that is how we can see the predicted values. And we can check 38. Let's check what 38 in mathematics. Mathematics 30, 38 is just below 40 there. Then our Y value can see it will be somewhere there. It will just be around that area there. Right. Now let us move on. Now let's say they're saying if a learner obtains 70% for science. Remember, when you are given science, you first locate where is science. Is science my Y or it's my X? Let's go and check. Check our scatter plot what we had. we see that our science is on the x-axis. That means this 70 will represent the x value. Predict the mark that they will get for mathematics. Remember, our mathematics is on the y-axis. So this is y. So in this case, we're looking for y. We are given x. So we're going to use the equation of the line of best speed. We substitute x is equal to 70 as x, or as we are given that the 70 is for sine and sine is on the x-axis. Therefore, that 70% is our x value. And we solve for y, where y is our mathematics and it is on the y-axis. Now, when we solve, we say y, because the equation for the line of best speed, in that case, we'll say y hat is equals to 6,1 plus 0,8, 1x. Then we say y, we substitute in the space of x, what we put? We put 70 there. Right. Then y is equal to 6,1 plus 0,81 into 70. Then y is equal to 62,8. Then we interpret the result. So a learner who obtains 70% in science, we can predict that they would get, or they might get 62,8% in mathematics. So we can see there. Let's go to science. If you just think about it, it's going to be around there. The 17 will be between 80, 60. Then you can see that the 62 will be somewhere after 60. So the value will be around that area there in that case. Right. Now, grade 12, I will give you 10 minutes to complete this activity. Right, welcome back, grade 12. Now, let us discuss the solutions to this activity. So, this is what we are told. So, the activity reads as follows. The following table shows the ages of 10 men and the mass that they can bench press. Now, we have age in years and mass in kg. Remember, age, we can see that this is even time. So, age in years. So, this will be our x and this will be our y. So, as I've mentioned, x will be the first and y will be the second. The one that will at the bottom, unless stated otherwise, or unless we can see what we do with time. And time is an independent variable. We cannot control time in this case. Right. So we are saying we have x values there and we have the y values in that case. Question 1, draw the scatter plots of the data. Question 2, determine the equation of the least squares regression. 3, sketch the least squares regression line on the scatter plot. Calculate coefficient of coefficient. Interpret the results and give us an estimate of a 50-year-old. We're estimating the mass that they would be able to bench press. Now, number 1, they said draw the scatter plot of the above data. So we can see our age is in years, it's on the x-axis, and the mass is on the y-axis. Then we work with that from there to say, okay, 30, 75, you can say age 30, 75 is there. Then you plot all of the values in that case. Then you go to question number 2. When you go to question number 2 says determine the equation for the least squares regression line. So how do we determine this? Remember, we utilize our calculator instruction, and this is our a plus bx. So this is y hat is equal to a plus bx. So in this case, we can see the value of a, it is 72,49. Our b is negative, that's why there's a negative there. It's negative 0,444. So that is to say we have a plus and there's negative. The negative times a positive, they will give us a negative. So a b is negative. As we can see, remember our b is a gradient. When the gradient is a negative value, we know that we are bound to get a decreasing function. Now let us look at this. So this is the equation. So we'll actually plot this line on that scatter plot. So they say sketch the least squares regression on the scatter plot. So how do we plot the equation? Remember, we know that this equation or this line passes through the midpoint. So we use the calculator instructions to find the midpoint and the midpoint x value and the y value. And we find the y-intercept. Our y-intercept is this one. Our A, remember, is y-intercept. So our y-intercept is 0 is to A. So our A value is 72,49. Right. So what do? You plot the 2 points, the mean value there, you can see it is there, one at the middle there, and we now get our y-intercept. So you can see that our line is giving us a decreasing function. Why is the rate of regression decreasing? It is because of the B. Our B in this case was negative. And remember, our B represents our gradient. So that's why the line is decreasing. Right. Calculate the correlation of coefficient and interpret the results. Remember, what are we doing in this case? We are using the calculator instruction. When you use the calculator instruction, we find our R as negative 0,39. Now this 0,39, it ranges between negative 0,3 and 0,3. So you can see where we're having a weak negative correlation. If we can now think about extrapolation, interpolation, because we are going there, you will see that the moment our R, it gives us a weak relationship, then the predicted value that we're going to get from our line of best fit equation will not give us the reliable result. Reliable result is when we have a strong relationship. When it's weak, the results are bound not to be reliable. So they might not be reliable in this case. It's a weak negative correlation. Why? You can see that the points are actually scattered around. You can see that they are not concentrated around the line. So it's weak correlation because most points are just scattered around the line there in that case. So that's why we have a weak correlation. Strong correlation, most points will be closer to the line. Weak correlation, they will be scattered or they will be a bit far from the line. Now, let us move on. Right. Let us look at E. E says to say, what would you estimate a 50-year-old would be able to bench press? How do we do this? Remember, 50-year-old. What is this? This 50-year-old is our age. So this is our age. This 50. Then where is the age? Age is on the x-axis. Right. So age is on the x-axis. What does this mean? That means the value, this 50 there, it is our value of x. So that's what the 50 will represent. So what do you do always? Check what is given and check where the value that is given. Is it on the x or on the y? If it is on the x, that means that value it represents the x value in our equation. Then what do you do now? They say, what would you estimate a 50-year-old man would be able to bench press? So that means we're in this case, we're looking for the mass. Would be able to bench press. So our mass is on the y-axis. So we're looking for y. So we're using the equation of regression, which is y is equal to 72,49 minus 0,44x. So we substitute in the space of x, we substitute 50 as we are given that, and we solve for y. So we code the equation, then we substitute 50 in the space of x, then we get our y as 50,49. Now let us look at this. A 50-year-old man will be able to bench press 50,49. So we can check 50s will be around 50 something. We can see the value will be around there. If we plot that value in that case, so it will be around that position. Now, I've been mentioning interpolation and extrapolation. How do you extrapolate and interpolate? Again, so in this case, our R there, like I said, when it's weak, it's actually giving us non-reliable results. So R, when it's weak, and extrapolation, they will have a special relationship because both of them, they give us they're giving us our unreliable results or less reliable results. Now, what is interpolation and extrapolation? Now, interpolation and extrapolation, what are we doing? If a variable it is not in the data set, so that is to say, we are talking about a variable that was not given maybe in our table, that is our data set in that case. So let's say they just give us any value that is not in the data set there to say find the other value. So to find, let's say they give us an x value randomly to say x is 5, then find the y value. So what are we doing? That is interpolation and extrapolation. Why? Because the x value that we are talking about was not part of the data set initially. So interpolation and extrapolation, it is when we are looking for other values that are not or that were not part of the data set initially. So this is what we are saying. If a variable is not in the data set, say X, then the corresponding Y value, these values are predicted. So extrapolation, interpolation, what are we doing? We are making predictions about values that are, which were not part of the data set, by reading off the line of best fit or from the equation of the line of best fit. So that is what we're doing. So we're reading from this line, or we're reading from the equation of the line of best fit. So this is what we know as interpolation and extrapolation. Interpolation and extrapolation. So let's say they just give you a certain known Y value, then any corresponding X value. So we're going to interpolate and also known Y value, corresponding X value, and that is extrapolation. As you can see, the first one there, it is within the line, the other one is outside of the line. That is to say, interpolation is within the range, extrapolation, it is outside of the range. Let us go through this in detail. Interpolation, we are saying, it is a term that is used to predict the value which lies within the domain of a domain and range of a given data set. That is to say, this is the one that lies between domain and range. Remember, domain is a set of X values, range is a set of Y values. That is to say, when we interpolate, we are predicting within minimum and maximum. So if you are saying the value must be between our X and Y in that case. If maybe our minimum, our X and Y values, let's say we are between 0 and 8. So when we are interpolating maybe 6, that was not even in the data set. Or when we are looking for 6, as it was not in the data set. So what are we doing in this case? We are bound to say, or we are saying in this case, we are interpolating. So that's what interpolation means in this case. So that is to say, we are saying we are given a certain range from this value to this value. If we are looking for the Y value that is within, the corresponding X value will be interpolated. So that's what we mean inter. So inter means inside. That is an estimate of the Y value for an X value that lies between the smallest X value and the largest Y value in the given data set. So that is to say, it is the one that is lying within the domain and the range. Domain, set of X values and Y values. So it is the value that is within the minimum and the maximum of our data set. See, if our data ends at 8, we're talking about a value, maybe the data is from 0 to 8 as I've mentioned, then any value that is between 8 and 0 and 8 that you are using, you are interpolating. So it's corresponding value. So interpolation, we are saying, let's say maybe this point, it is between, so this is between this point and that point. So the minimum point is this one, the maximum point is that one. Any value that you find or that you are looking for, which is within this highest, and this is our mean. Any value that is found between, it is interpolation. Now what happens if the value it is outside this minimum and this maximum point? So what do we call that? We call that extrapolation. So extrapolation in this case, it is the term that is used to predict the value that lies outside the domain and the range of the given data set. So this is outside the minimum and the maximum. So what are we saying? That is, this is the estimate of the Y value for an X value that is greater than the largest X value or smaller than the smallest X value in a given data set. So this is what we are saying. When we are extrapolating, we are having, this is the highest point, this is the lowest point. So this is our max and this is our min. We can see that the value that I'm looking for, that we're interested in, is outside of this. It's not even following on our line then. So what are we saying? We are extrapolating as this value, it is outside the maximum value, or it's somewhere here. If the value is somewhere here, which is below the minimum value, that is extrapolation. Interpolation, the value must be between the minimum and the maximum point. If you look for the value A there, that will be interpolating. Now, if maybe you're extrapolating, maybe value B, it is somewhere outside of our maximum and our minimum range. So any value outside, extrapolation. Within the minimum and maximum, interpolation. Right. Now, let us look at example number 2. So, now in example number 2, we are told that the table below gives the height of boys between the ages of 1 and 17. So age in years, starting with it is x, and this is our y. Age in years is 1 to 17 there. Our height, which is on the y-axis, will be from 70 to 170 there. So those are the values that we have there. Number 1, draw the scatter plot. Number 2, determine the equation of the line of best fit and draw the line of best fit on the scatter plot. Determine the correlation of data and comment on the strength. How tall would you expect a 13-year-old to be? If someone is 155 centimeters, how old do you expect them to be? And determine the expected height of a 40-year-old man and comment on the reliability of the height. That is very important thing. Now, draw the scatter plot of the above data. So age is x and height is our y. So we plot all of these points. So height is y there, and you can see our x values as our age in that case. Thereafter, let's look at number B. Number B says determine the equation of the line of best fit. Remember, we use the calculated instructions. We plug in the x values and the y values. Thereafter, what you do, we now get our equation. Remember, our equation is given as y is equals to a plus bx. That means our a value in this case is 70,10. Then our b, it is that one there, which is 5,58, then x. Now remember, we are now finding the equation. That is the equation, and we draw the line of best fit on the scatter plot. Remember, the line of best fit, it passes through the midpoint. So the x value of the midpoint is 9, and the y value, so this is the y value, y bar, x bar. So the y value there is 128,3. And the y-intercept, remember, y-intercept is 0 is to a. Our a in this case was 78,10. Now, let us draw that point. So we plot the one x value, which is the x of the mean, and the y of the mean point. So the x is there, it's somewhere 9, between 8 and 10, and our y is between 120 and 140. Then we start from there, we connect the y-intercept and the mean value, and we just draw a straight line until you cover all of those points in that case. Then that's how the line of best fit looks like. Right. Already, as you can see that most points there, in this case, they're actually scattered around the line of best fit. So we're expecting the correlation of coefficient to be strong. Remember, we will find this correlation of coefficient using our, we're going to find this equation, this R using our calculator instructions. So that is what the question says. Determine the correlation of data and comment on the strength. Our R, when plotting all these points on the data, is 0,96. Then we can see that it is positive because it is giving us an increasing function. It's a strong positive relationship. So this is R, this is the relationship. Now, we can see that because R is this, it's 0,96. So the values that we try to predict in this case, they will be more reliable. So the equation of the line of best fit will yield more reliable results when we are trying to make prediction of other values. Why is it reliable? It is because of the strong relationship. So that's why we are bound to find the reliable ones. So when R is strong, we are bound to find the estimated values as reliable. Now let us move on. So they said, how would you expect a 13-year-old to be? And comment on how reliable this height is. Let us check. 13-year-olds were given an age. So the age is 13. So you go to a scatter plot. Where is the age? Our age is on the x-axis in this case. So on the x, we have an age of how much? 13. So x in this case will be what? 13. So that's what will represent our x value. And now, how tall? So tall, we are talking about the height. Go to the scatter plot. Where is the height? Height is on the y-axis. That means to find height, we are looking for, or we are solving for y in this case. And comment on how reliable it is. We are using the equation of the line of best fit, which is y is equals to 78,10 plus 5,58x, which is a, and this is our b. right? So we are saying in the space of x, because x is 13, we substitute 13 there in that case, then we find our y. Now we interpret to say y is the height, so this is the height of this 13-year-old boy. Now we are saying a 13-year-old would be, so a 13-year-old will be 150,64. This height is very reliable. So you can see, even if you go and check, there's a strong correlation between the age and the height of the boy. So there's a strong correlation. How do we see the strong correlation? Let's check. 13 will be found somewhere there. Then when you look at the 150 there, so 150 will be somewhere there. You can see that the point, there's a strong correlation. At the point, it is also closer to the to our equation of, to the line of best fit in that case. So there's a strong correlation because that value, it is closer to our correlation in that case. So that's what we are doing, or the point is somewhere here. So that's what we are doing in that case. So it is closer, so it is strong. So this height is very reliable. Remember, even that R of 0.96, it showed us that we are bound to get an estimate that is reliable. So that's why this value is more reliable. Right, let us move on. If someone is 155 centimeter tall, how old do you expect them to be? 155 centimeter tall. Now, I want us to go back a bit to our table. Let me just go back to the table. The table. I want us to just to check. Okay, it's fine. We look for the table. Let's just use the scatter plot. See that it's taking time. Right. Now, I want us to look at the scatter plot. What are we looking for? We are checking where is this 155 centimeters. Now, 155 centimeters, our highest value there, it was there. It was just below the 155. Right. So it is below or within. So we can see that that value is within. Now, if someone is 155 centimeters tall, how old do we expect them to be? So here we are looking for the age of this person. So in this case, we will now say use the equation y is equal to 78,10 plus 5,58 and substitute in the space of y. Remember, if someone is 155 centimeters, what is this? This is my height. Where is my height? My height is on the y-axis. So this 155 centimeters will represent my y value. How old? How old? It's what? It's age. So it's on the x. So we are solving for x. We are given y, solve for x. Then we say y is equals to 78,10 plus 5,58. Then what we do, substitute y is equals to 1,155 and solve for x. Then what is y? Y, in the space of y, you put 155. After quoting the equation there, then you solve for x, and x is 13. So approximately, this person will be how much? 14 years old. So 155 centimeters, somewhere there, then this person will be approximately 14 years old. You can see that this value, it is interpolation. Why? We didn't have 155 centimeters in our data. So how do we now see? This is interpolation because it is within. You can see that our highest value is there right there in that case. So this is within our range. So we are interpolating in this case. And this is what I was supposed to mention on the previous one. So interpolation, because we didn't have 155 in our data set, so we are predicting a value within the data set. So we are interpolating. So the interpolation, approximately 14 years old. If someone is 155 centimeter tall, they would be 14 years old. They will be predicted to be around 14 years. So that is the age in that case. Right. So that is what we are dealing with in this case. So that's how we apply interpolation and extrapolation. Right. Just to go back a bit to our table. Now, when you go to the table, why am I saying the 155 centimeters there? So why am I saying the 155 centimeters is our interpolation? So we'll go back there. That was interpolated value because the highest value we have is 170. So in that calculation, we're interpolating because our height is 170, and when we can see that, that value that we're interpolating, which is 155, it is somewhere there. So the highest is right there. So that value there, like I said, it is our interpolated value because it lies within the range and it was not part of our data set. So that's why, or that's how we apply interpolation and extrapolation. Right. Let us move on to number F. Now, when you look at number F, they say, determine the height of a 40-year-old man and talk about its reliability. So our highest age was how much? It was 17. So 40 years is way above 17. So what are we doing here? We are extrapolating because our highest is how much? Is 17 and we are looking for 40. So let's see the extrapolation. Now, so we're saying determine the height of, so we're looking for the what? The height. Height is on the y-axis, so we are solving for y. We are solving for y. So we solve for y, and we're saying 40, so we are given an age. So age is on my x, so x there it will be 40. And comment on the reliability. Use the equation, substitute x is equal to 40. So in this case, and solve for y. So what are we saying? In a space of x to put 40, then we have 40 there, we solve for y, and y is stronger than 1,30 centimeters. That is to say, according to this extrapolation, a 40-year-old man would be greater than 1,30 centimeters. This height is not reliable. Why? The x value is far from the highest x value. So our highest x value is 17. And the value that we are extrapolating on, so we have the highest value is 17, but we are extrapolating at 40. So 40 is too far from the highest. So what are we saying? It is not reliable because it is extrapolated too far. So if you can check, let's go to 40, you'll see that 40 rather than something is way outside of our data set or the range of our data set. So that's what we are saying in this case. To say this expected height will be very, it will be what? It will be way out of the data set. So this will not give us reliable results. So most of the extrapolated values are not reliable. It's more like that weak correlation of coefficient. It's likely to be unreliable. Now, activity number 2, grade 12, you are also given 10 minutes to this one to complete this activity. Right, welcome back, grade 12. Now, let us go through this activity. So, this is what is happening. So, the activity reads as follows. A farm stall sells a milk in a 5-liter container to a local community. The price varies according to the availability of the milk at the farm stall. The price of the milk in rands per 5-liter container and the number of the 5 liters containers are recorded in the table below. So they even tell you the price of the milk is the X and the number it is our Y. So they even told us in this case. This was a paper. It was a November paper in 2021. So it is our exemplar. Right. So what we have in this case, you can see we have the X values there and we have our Y values. So what are we doing in this case? On the provided grid on the answer book, draw the scatter plot to represent the data. So let us look at the scatter plot of this data. So this is how the grid will look like in our answer book. So this is how you draw the scatter plot. So that is the scatter plot you draw from the whole of that table. Right. Determine the equation of the list of squares regression. Remember, we'll find it using what? We'll find it using a calculator. We find the value of A, the value of B, then we substitute in the equation A plus bx. Our A, it was 90,48 and our B, it was negative. This is negative, so it is negative 1,77. In the space of B we get negative, so that's why we have Y is equals to A, which is 90,48 minus our B, which is negative 1,77x. Now, so this you can see B is negative, so B is negative. So already we are seeing that this is going to be a decreasing function because of the B is negative. Because B, remember, it represents our gradient. Right. Now, the same, if the farm stall sells 5-liter container milk for 38 rands, predict the number of 5-liter containers he will be able to sell. Now, what do you do? Check. 5-liter container, so these are the rands. You check, where is the price? Is the price on the X or on the Y? Our price is on the X axis. So that's where the price is on. So if the price is on the X axis, so we are saying we are given X is equals to 38, which is the X that we are having in that case. And predict the number of 5-liter containers. So the units are on the Y axis. So that means we are solving for Y. So we are given X. So we locate that X there. And we are solving for Y. We code down the equation because we're using the equation of a line of best fit. We have the equation. Then in a space of X, what do we substitute? We substitute 38 when we find our Y value as 22,22. If the farmer sells a 5-liter container of milk for 38 rand, he will sell approximately 23,22 units of 5 liters of containers of milk. So that's how we are interpolating in that case. So how are we knowing that we are interpolating? Because this 38, it is actually below. Remember, our highest here is 40. So our highest X value there is 40. So 38, it is somewhere, 35, 36, 37, 38. It's somewhere here. So it's somewhere on this line, which is within our range. So we are interpolating. So interpolation and extrapolation, remember, 38 was not in the data set. So we have interpolated the Y value of that 38. So the corresponding Y value in that case, which is 22, something. So 22,22, which is somewhere after 20 days, which is somewhere there. Right, that is interpolation because the data, the value is within our range. Let's move. Refer to the correlation between the 5-liter and the milk and comment on the accuracy of your answer. What is our R? Our R is negative 0,94. So R indicates a strong relationship between the cost of 5-liter and the unit sold. There's a good chance of the prediction being accurate. Remember, it is strong. So when it is strong, the prediction or the predicted value, it is bound, or there's a good chance of it being accurate. So that's what we mean when there's a comment on the accuracy. So when you comment on the accuracy, you are looking at R. When R is strong, it is accurate. Whether strong negative or strong positive, it is accurate. It's likely to give us accurate predictions. Then when R is weak, so we know that the accuracy will be very low. So the result will be less accurate. Or we are predicting the result to be less accurate. R is negative, you can see that the data plots are going down, and if we draw a line of best fit, it will decrease in that case. Now, grade 12, this is our homework, so I will give you 5 minutes to only copy this homework down. Right now, grade 12, remember this homework is going to be marked, or we'll discuss it on our next lesson. Right now, let us look at the summary of this lesson. So in this lesson, this is what we've dealt with. We have dealt with the scatter plot. So what is a scatter plot? It's a representation of a bivariate data. So it's the data concerning two variables, which is X and Y. So where one it is plotted on the X and the other is plotted on the Y. What else? The correlation of coefficient, it is to give us the strength of the relationship between these two variables, which is the bivariate data. And this R, it lies between -1 and 1. Where -1, it is the strong negative correlation, and 1, it is the strong positive correlation. We are using the regression line, which is the line that is drawn on the scatter plot to show the general trend. General trend, that is to say, where most points are actually at. The bivariate data seems to follow. This is to show you that whether the trend, the data are closer to each other or they're far apart from each other. When they're far apart from each other, we'll get a weak correlation. So these two, they go hand in hand. The correlation of coefficient and regression line, they go hand in hand in that case. The least squares regression line is a straight line. So what do we do? This is the least square regression line. And in grade 12, we are dealing with a straight line that passes through the mean point of the relative bivariate data and the y-intercept. So that is where the line passes. Right. So that is what we've dealt with in this lesson. Again, from those data that we've received, we have used interpolation and extrapolation. What were you doing? So when we interpolate, we are predicting the value which lies within the domain and the range of the data set. Remember, our data set, we have certain values. We are predicting a value that is not within the data set, that is not in the data set, but that value is within the minimum and the maximum values. So that is interpolation. Extrapolation, we are predicting the value that lie outside. So in this case, when we are extrapolating, it is a value that is outside of the domain and the range of the given data set. That is to say, this is the value that is more than the maximum point, or it is less than the minimum point. Right. This is what we'll deal with on the next lesson. So next lesson, it is probability. So this is the grade 11 revision. So we'll revise the identity, which is the addition rule. We'll talk about the addition rule for mutual exclusive events. Complementary rule will identify dependent and independent events, and the product rule for independent events will use the Venn diagram to solve problems, deriving and applying the formula for any 3 events in the sample space and the 2 events. So we'll deal with the 2 events and the 3 events, and we'll use the tree diagram for the probability of consecutive or simultaneous events which are not necessarily independent. Also, we will also look at the contingency tables. Right. Thank you so much, grade 12. Enjoy the rest of the day. We'll meet again in our next lesson.